Final little video of first trimester, 4-5, only day of 4-5, couple sample problems, few. So, don't know if I've been emphasizing this enough in the pre-lesson. I know I stumbled upon one, but I never really made sure to warn you guys. When you see x in the denominator, the first thing you should do is ask yourself the question, what can't x equal? Remember, the domain can't have zeros in the denominator. So when you start these problems, these are slightly different. Remember, if you have problems like this, 3x plus 6x equals 7, they're really, the denominators are all 1. There are no variables in the denominator, so you're not even concerned about it. Then all of a sudden, these buggers show up. You've got a whole another thing to worry about, and you should take care of it before the problem even begins. So, what can't x equal for this one? X cannot equal 7, because that would cause that to be 0. How about this one? Well, if you look at both the denominators, x can't equal -5. This one, you can see two things x can't equal. X cannot equal -2, cannot equal +2. Same thing's true here. So that's what you should look at before you even get started. So now, what did I impress upon your minds? I hope you want to get rid of that denominator. We're going to multiply this side by x minus 7 because we have to multiply this side by x minus 7. Remember, our goal is to cross reduce, swoosh. And here comes the cross reduce. So we're left with 1 equals, then we distribute 2x minus 14. Now it should be easy peasy. Add 14, add 14. So I get 15 equals 2x. I'm going lefty. 2, 2. So my answer would be 15 halves. I need more practice in the left hand. Equals x. So, because this is 15 halves and it's not 7, this is my solution. So, what if my only answer was 7? And this problem would be no solution. But we found a solution that's not equal to the thing that x can't be, so there you have it. There's our answer. So, let's go on to the next one. Number 2, I know that x can't equal -2 or 2. Look at this crazy thing. I put parentheses around that, and I say, hey, I got to get rid of my denominators. I got to multiply by whatever is going to absorb every denominator. So this is the meatiest denominator, so I'm going to focus on this and say, hey, I got to multiply it by x plus 2, x minus 2, so that these will cancel. But that means I got to do the same thing to this side. So I need a little more space here. So this looks crazy, x plus 2, x minus 2. This is the easy side because everything cancels. I end up getting equals 4. So if I look at this and I think of this as over 1 and I distribute it to this first thing, notice my x plus 2 is going to cancel with this x plus 2. I'm not going to cross it out because I know I have to multiply by that 2. But the x plus 2's cancel, so I'm left with x minus 2 times 1, so that's just x minus 2. But then I got to do it again. Now x minus 2 cancels with that x minus 2, so I'm left with x plus 2 times 1, which is just x plus 2, equals 4. And again, now I just solved this. X plus x is 2x. These 2's cancel. And I get equals 4, divide by 2, divide by 2, and I get x is 2. But wait, if I just move on to the next problem and I'm not thinking, remember x can't be -2 or 2? We got x is equal to 2. It can't be, because that would cause this to be 0. Can't have that in math. So this is a no solution problem. So look out for those. A little different twist on this one. Notice we got an x squared. Don't worry about it. But think about it, something different's going to happen. X can't equal -5, we'll put that over here. Now we're on a mission to get rid of that x plus 5. So I'm going to multiply by x plus 5. Those cancel. But then I got to multiply this by x plus 5. Those cancel. So I'm left with x squared equals 25. Now, remember what I taught you? You get this situation, bada boom, bada bing, do the right thing. So I get x is plus or minus 5. But wait, x can't equal negative 5. So I know that plus 5 is the only thing that will really solve that problem. Okay? All right, I'm going to pause that. This example has something a little unique in relationship to the previous problems on the pre-lesson and the previous problems on this example problem video. And it's right here. So remember, I just got done saying, hey, there's a new responsibility. You got to look at the denominators right away and say, hey, what can't x equal? Well, that should jump out at you. X can't equal 5. And x can't equal 3. But then you look at this and you're like, whoa, what the heck is that? Exactly, it's a trinomial. It's like a doctor hits you on the knee and you'll go, you only have one response. Bing! You got to factor it. So it's x and x. 2 factors of 15 after negative 8 would be negative 5, negative 3. Notice these match these. You see, these math people aren't that evil. They're going to make things work out for you, so just take that as a hint. That's probably going to be an always. If these don't match this, the problem's going to be massively difficult. You can do it, but that's not what our goal is right now. So, I know that this denominator is now x minus 5, x minus 3. If I look at this, I'm like, ooh, that's the bad one. So I know I got to get rid of all of it. But then if I multiply that side by this, I got to multiply this side by the same thing. Very similar now to the previous problem, but you had to factor that denominator first. So be on the lookout. If there's a denominator that's factorable, you got to start there, okay? So now, this is the easy part because that all cancels. So I get 2. Now here comes the difficult part. I'm going to put this in parentheses. I'm going to say, okay, this fraction times this fraction, my x minus 5, I'm just going to underline it and then cover it. The only thing left is x minus 3 times 1, which is just x minus 3. And then I have to do it again. So the x minus 3 cancels with the x minus 3. X minus 5 times x. If I distributed that x through both things, that would be plus x squared minus 5x. So like, okay, wait a minute, this is looking different. You got that x squared term, which means you're going to have to deal with a trinomial. Keep your x squared term positive, so I'm going to add 2 and add 2. Because you've got to set this equal to 0. Put things in descending order, so I got my x squared. X minus 5x is negative 4x. Negative 3 plus 2 is negative 1 equals 0. Let me check something. Okay, demonstrating some of my humanity. The reason I paused right there is I got down to this trinomial, and I didn't think any of these trinomials that we end up in this section end up forcing us to go into quadratic formula, because this is not factorable. Did you pick up on the mistake I made? I did, but I kind of thought so. So if this does happen, don't panic. Just go right into quadratic formula. I just didn't think any of this quadratic formula thing was necessary in this section. So I'm like, wait a minute. Look at it. Why did I add 2 there? I'm supposed to subtract 2 to get rid of it. Did anybody else pick up on that? So that wouldn't be negative 1, it'd be negative 5, and then voila, you can factor this thing. So 2 factors of negative 5 that add to negative 4 are negative 5 and 1. So I get 5 or negative 1 for my solutions. But wait, x can't equal 5, so negative 1 That's not in my list of things X can't be. That's the only answer for this solution, for this problem. There, it was a battle, but we did it. One more sample problem, guys. Okay, the last problem of this entire trimester as far as the video goes is example 5 on page 228. You can look at it, but I'm going to condense it a little bit, try to explain it. If you've never done a problem like this before, it can be quite confusing, but after you try a couple, it should make more and more sense. So the problem basically says, this guy's in a boat in still water. The speed of paddling a canoe or a kayak is 5 miles per hour. Then it goes into this little story. The guy in the boat goes with the current. Now we don't know what the current is, so we're going to call that C. So his speed going this way is going to be C plus 5. That's the rate if he's going with the current. It's his regular speed plus the assistance of the river. But then, and then he goes 16 miles. Notice the two things we're talking about are rate and distance. So I'm going to pause there. The formula we're going to piggyback is distance equals rate times time. But remember I said rate and distance are the things they really focus on. So we're like, okay, we got to build a formula that uses those two things. So if we divide both sides by R here, we get a different formula right here. Time equals distance divided by rate. We're going to use that formula. So when he's going this way, which I'm going to use purple, and then when he comes back, I'm going to use red. The distance he goes is 16. Now his rate is his regular speed plus the current speed. Now, interestingly, it says that he paddled this way for 1 hour longer than he did that way. So what we're going to say is he paddled 1 more hour going that way than he did this way. Then the problem changes a little bit. Red marker, takes a break, gets back in the boat, starts paddling against the current. Notice his speed is not going to be 5. It's going to be less than 5 because he's battling the current. So the situation over here is his speed 5 minus C. So he's battling the current, but it says he only goes for 6 miles, which is the distance. That's where this comes from. And then you have this formula. So you've got his time represented here. It's he's going with the current 1 more hour than he is paddling against the current. And now we've got an equation that we can deal with and solve. So let's do it, just like we've been doing it. So this is 5 plus C, this is 5 minus C. So to get rid of both of them, we got to multiply by both of them. Now this could get a little hairy, but here we go. Multiply this times this. 5 plus C's cancel. I got to multiply the 16 by both of these things. So I get 80 minus 16C. Now look at it. This stuff times 1 is just all of this stuff. So it's 5 plus C, 5 minus C equals, I'm just going to, so I went here and I went here, now I'm going to go here. The 5 minus C's are going to cancel this time, and I'm left with 5 plus C. Now the reason it's got a slash through it is because I slashed it right here. I shouldn't have, but 5C is still, 5 plus C is still left. Times 6 would be 30 plus 6C. Like I said, this is getting a little hairy now. One thing I didn't do was take a look at what can't C equal. Well, C cannot equal -5, and C cannot equal 5, because that just doesn't fit in our domain. You can't have zeros in the denominator. Now we got some work to do, so 80 minus 16C plus, I gotta see how much time I have, hold on. So check the book for the rest of the math. Apologize for that.